Okay, this is going to be the first video of probably a 3-video set talking a little bit about some of the object-oriented features of C++, or some of the features of C++. Not all of them are strictly object-oriented. If those of you who see this who are in my first semester class, this is probably going to be familiar in terms of concepts because you probably saw this in Java in your APCS classes in high school. And those of you who are in my class in the spring semester, this will be new, but there'll be additional information on the, in the actual page that links to this video, so you'll be able to get that as well. So first off, you all know that I'm not really a huge object-oriented programming person. I lean more towards functional these days, and I think a lot of people talk about object-oriented over the years has been overblown. It's not a silver bullet. It's a paradigm. It's a useful paradigm in certain areas, but I also think that some of these killer features, or what were purported to be killer features, really aren't. And the one we're going to talk about today is inheritance. The idea that you have a class that has stuff in it, and then you have another class that's similar, but maybe a little different or maybe a little more, and instead of making them as independent entities, you inherit from the base class, and that gives you more interoperability and flexibility, etc. And it sounds great, but the truth is, most applications don't seem, at least in my experience, don't seem to really benefit that much from it. It's just that's not how problems work. Problems are more constrained. To me, the benefit of object-oriented programming is just the class itself, not the inheritance, but the class. And in the class, it's giving you this encapsulation. Like over here, I've got a bike class where you have the maximum speed, and you can. I don't have a method for this. I guess I could make a method. Let's make one more method. Void set max speed. Double S. And let's go to bike.cpp, and we'll add one more here. We'll add avoid bike set max speed double S, and it will be max speed equals S. So anyway, you can set the speed, you can get your speed, but you're maintaining the state. So all the things that are your bike in this case are in here in this private stuff, and you interact with it in the world. You say, what's my maximum speed? What's my speed if I give a certain effort? And I'll set my max speed, and I just have the stupid greeting to have another one in here. That's the benefit, this encapsulation and management of state. So if you're doing video game, your spaceship bad guy would be a class, and you'd have multiples of them, and each one would have its own direction and velocity and damage, etc. That makes a lot of sense. And I believe in that. I think that's great. But to me, inheritance hasn't come up that much. I mean, I think that library creators, they would find it useful. You're writing a library to do a whole bunch of stuff, and people will extend it once for their own thing. Things like if you're going back to Java, if you use Java interfaces, which is related to this, that makes a certain amount of sense if you're creating those. So you might use things that have inheritance that other people wrote. But in my experience, you're probably not going to write it that much, and that's okay. And if you do write it, you still want to understand it. Even if you don't write it, you'll want to understand it if you're using it. So anyway, we've got our class here. And so notice it's a bike. I got a couple of constructors. I've got get the speed, set, whatever. I can do all of this. And then here on my implementation, it's pretty simple. My default constructor sets a max speed for 25, which is reasonable. I guess you could go faster. I know when I was younger, I would sometimes hit 30 on a downhill or even faster on a downhill, but not so much anymore. But that's fine. 25 I think is reasonable for like a normal maximum speed. You can also set the max speed. You can get the max speed. Your speed, let's just say it's your effort times your speed. So if you're giving an 80% effort, it'll be 80% of your maximum speed, just to have a method there. And then we'll just have this little greeting. And then over here in our main, we've got, we're just going to test it just to show it. So we make two bikes, one with the default constructor, one with the other, and then we just run some of the methods. And I put together this make file, which is just the normal deal. And so if we compiled and run this, we got an error. Oh no, well that's because I was going with our extension, which is an eBike, but we don't have eBike right now. And there we have it. So that works, it's fine, it's all good. This is stuff you've been doing in your last couple of labs. So let's talk about inheritance. So let's say I wanted to make an e-bike. So an e-bike, a power assist bike where it has, you still have to pedal, but it has a motor to help you out. So we could do that. We could make, not if I'm over there, I can't. We could make e-bike, and let's start with the H file. And we could, and here I've actually still have it created from before, and we'll just write this. We could just start to create our class, and we could put everything in this. And if we put everything in this, then we just be like, okay, great. We're going to, we'll have two different things, the bike and the e-bike, but that's not inheritance. That would just be two separate copies. But by saying this magic part here, an e-bike extends a bike, now e-bike is essentially inheriting from bike. Now it's not exactly a copy, which we'll see in a minute. It inherits from it. So let's take a look at this. Let's take a look here at our main. And now let's include ebike.h, and notice that ebike has nothing in it, though there's no CPP. It's just saying, hey, we're extending bike. So let's see if we can do this. Let's say, let's just do this with B1. Let's make this into E1. And instead of a bike, this is going to be an e-bike. Now, since we're including that and there's no actual C code, it's just definition, this should just compile. And it does. And notice we get our e-bike on the bottom. That all works. It inherited it. Now, let's see how this inheritance is actually working. So let's say we wanted to do something. Well, we've called the methods here. Let's call something else. Let's say e1 dot set max speed to 50. And that seemed to work, so it seems that we've pulled all that stuff in, but it's not exactly that simple. Let's look at our bike.h. And notice here that we've got max speed. And let's say we want to work with the max speed. Let's say we want to let's say we want to do something else with the max speed, like I don't know. Let's say we don't want to set the max speed in a bike. So I'm going to take that away here. Well, actually, I don't even use this up here. So we're not actually setting the max speed. So let's just take that away. Let's go to bike.h or bike.cpp. Let's take away setting the max speed. So we're no longer setting the max speed. Make sure I've done that right. I didn't do it right because I'm trying to set it here. But let's comment that out. And now let's say we do want to set the bike, but we don't want to allow us to set the max speed for a regular bike because that's just 25. It's the laws of physics and whatever. So let's just go into our e-bike. Whoops. Let's go into our ebike.h. And let's just say we're going to have a method here. And our method is going to be, nothing big, we're going to have a public method. And the public method is going to be void, what is it going to be? Set max speed, double S. And then over here in ebike, we'll have to go to ebike.cpp because now we need the CPP. And so we're going to include bike.h. We're going to include ebike.h. And now we're going to write that set speed routine, which is going to be void ebike : set max speed double S. And we're going to say speed equals S. or rather max speed equals S, sorry. Now this is not going to work, I'm going to tell you that now, but regardless, we're going to, let's just go to, let's just go to our make file, and let's add ebike.o, let's just add the stuff for there, ebike.cpp, ebike.h, and since it relies on bike.h, we'll need that as well. And so now this make file should compile, but this shouldn't work, or this, I'm hoping this doesn't work. And it doesn't work, and let's see, it says, notice that this is private. So notice that what we had before is we were able to use the bike stuff in eBike. This worked, get max speed worked, this worked. But even in the compile stage, it's saying, hey, you can't, max speed is private, you can't get to this. So if you were in, if you were in APCSA in high school, you might have seen that and said, well, oh, that makes sense because that's how Java works. The stuff that's public is inherited. So you get access to that. Bike is considered the superclass, and you get access to the superclass from your class, from the inheriting class, but you don't get access to the private stuff. Now you could do this. And I think this will work. And that worked. So we could now, or at least in theory, we can now, main.cpp, we can now set our max speed. Let's see, what do I call it? Set. Oh, sorry, it's got to be, no, that's right there. That's correct there. Void ebike set max speed. Set max speed. Let me just remove my .o file. And let's see what our mistake is. So our ebike has a public member function. Public bike, that's right. And let's go to our implementation. Set max speed. E : set max speed SS. E1 is an e-bike. And it should Why is it not finding set max speed? E-bike void set max speed. Oh, duh. Because it is I have to make it an e-bike, not a bike. Oh, but notice that it did let me do that because the types are related. Okay, so notice we can do this with the public, and that's fine. But you don't want to do that because, going back to ebike.h, rather you do want this to be public, but you don't want max speed to be public. So there's a third characterization, protected. And so let me get this invented right. So basically, stuff that's public, you inherit. And not only do you inherit it, but everybody can get to it publicly. And you know that. That's everything you know. Private is only within your class. But protected gets inherited. So now, if we now make it protected, this will still work, even though, but it's still let's say semi-private. You still can't access it from the outside. So that's most of what I wanted to show you. What I did want to show you is I wanted to show you a couple of other quick things here. So one of the other things that I wanted to show you is let's talk about constructors. So let's go to main, and let's say I try to say ebike e2 equals, or pointer e2 equal, and this is the pointer, and let's make this like a super fast bike, and it gives us an error because you know it's giving us an issue with the constructor, and you know, and even if I say, well, that's supposed to be a double, that gives me a problem. So we actually have to implement the constructor ourselves. And so let's go into ebike.cpp. And this is similar to what Java has as its restrictions. So it will be ebike:ebike double M, and then max speed equals M. And we still have an error here. Double me okay, still a little bit of an error. I want to get my syntax right and my little nuances right. ebike:ebike, that is correct. Oh, and this is no, and then and in the H file, let's see, that should just be under a public ebike double M. Let me remove, I should really put in a .clean because I think sometimes that has an issue. No. Do I also have to have the other one? I might also have to have the other one. Ah. So I'm having some stupid error here, which this is kind of matching my oh wait. No, that's okay. So what am I doing? What am I forgetting? Something silly. Bear with me for a moment. Let's start with this. Let's start with the G++-C ebike.cpp. No return statement for non-void function. But that should be okay because it is a constructor, so that should be okay. ebike::ebike with nothing after it. ebike::ebike. And that gets a double M. And in the H file, we've got ebike, semicolon, then an ebike, and those should be in the public section. So that should be okay too. So I'm going to pause the video and figure this out, but I will be back. Okay, so I'm back and I'm an idiot because I don't know how to write. Woohoo. Okay, so I feel kind of stupid now. But anyway, let's actually even see if we need this one. And let's get rid of this one here. And it looks like we do need that one. So, because we're calling it with just the basic one. So it looks like it's following the same basic rules as Java has. So this all should work now. And I think that's looking pretty good, but let's come into our main. And what we're going to do here is now let's say e-bike, let's get our notation right, e2, pointer e2 equals new e-bike with a speed of 100. Let's just change this, and let's just make this, and these have to be E2s. And that works, and then we could even, E2 set max speed back down to 50 just to show it main. Okay, so basically, this all works, and so that's kind of the guideline, is if something is public, it's inherited. If something is private, it's not inherited. And if something is protected, it is inherited. But protected is like private and is not accessible to the outside world. So now there's one last thing behind this, which is, what if we want, we want to have our greeting to be different. Now we could do this. And we could now go into ebike.cpp, and we could say standard string ebike, now make it uppercase, :greet. And it's bicycle. I think greeting is just bicycle, bicycle. And if I wanted to, I could be like return, I want to ride my bicycle. I want to ride my bike. And we'll just say, if we want this to be totally different, we can do this. And so now, standard string, geet. And now notice that the bicycle is bicycle, bicycle, and then as I want to ride my bicycle. But what if we wanted to build off of what we had before? Now it's like we can't really just, well, wait, we can't just call greet because greet is going to call myself recursively. So we have to specify we want from the class above us. Now, if this were in Java, if you were doing this, in Java, it's going to be, and I lost some code here. If you were doing this in Java, you would say super dot, because super is the super class, the one that it inherits from. But that's because Java doesn't allow for multiple inheritance. You can only inherit from one class. In C++, you can inherit from multiple classes, which can get really confusing. You can be like, I'm going to be, like, instead of just saying I'm from a bike, I'll be like, I'm going to inherit from a bike, and I'm going to also inherit from a motorcycle, and I'm also going to inherit from a unicorn. And you can do that, and you'll get all the methods from each. So you can't just do super to say which one. So what you do is you have to specify it, saying, like, I want to take from bike. So we'll say std string parent greet equals bike : greet. And you can do that to call anything in the super class, the bike class, and then we'll just return, let's just return the parent greet plus, and we'll just put a space there. And that's a parent treat, so let's fix that. So now if we come to here and we do our make, notice that now it's calling the parent class. So that's inheritance in C++. So I know, we got a little bungled there when I just wasn't seeing that lower versus uppercase letter. But anyway, it didn't, but actually that's a good point, because notice that was like, what the hell? And then I stopped the video to take a little more time to look at it. And so when you're looking at your errors and you're looking at something and then you fix it and you'd be like, oh, I'm so stupid, I should have seen that. Look, I've been doing this, I've been programming since I was like, I don't know, 11, 12 years old or something, and I'm like in my 50s now, and I'm still making errors like that. So that's really nothing to be, it's just the way it is. We all, you got to laugh at yourself. So anyway, that's inheritance, and it's important to know, even though you probably won't use it all that much. And this is the video for part 1. So that's it.